And up next, we have Goksel with Perceptonic.
Thank you. Am I on? Is this good? All right. Thank you very much. Well, good afternoon. It's a pleasure to be speaking with you all today. My name is Goksel Dedeoglu. I am the founder and lab director at Perceptonic. We are a small startup out of Plano, Texas. And today we are happy to share one of our early prototypes for drones and how it relates to the REAL conference and use cases. Well, my background is computer science, robotics, computer vision. What we do in computer vision is we enable machines to see. Generally speaking, we typically deal with image sensors. We take lots of data from image sensors. We pass them through algorithms that analyze the pixel values, and we extract useful information for machines to do useful things. For instance, a camera becomes a smart camera once it starts understanding the scene. It can tell how many people there are in the room, it can count objects, it can tell the distance to the outside world. Now, in this sense, computer vision is drastically different from human vision. We are all kind of spoiled by our cameras, TVs, smartphones and whatnot, in the sense that we are being presented better and better images, colorful, vibrant content. Computer vision works differently. It actually doesn't care too much about resolution or color. What it cares about is the information content in those images. So at times you are going to see these perception systems work with just grayscale images. You'll see them work with depth images or just hyperspectral images such as infrared images. Now, we are not used to these kind of unusual modalities, but they work sometimes better for vision because computer vision is different from human vision. Now, when you think about the conference, the exhibits you see, the talks you attend here, obviously it is the case that drones and data collected by drones is a big part of the 3D workflow. When you take a closer look, you actually realize that a lot of the machinery that goes underneath those solutions is inherently a computer vision algorithm. Say you send out your sensor, your drone is basically a carrier of cameras. It comes home, you upload your pictures to the cloud, and you start working on them. Well, when you start stitching those images to a coherent framework, those are vision algorithms that are figuring out how images belong together geometrically. When you start building 3D models, it's again vision algorithms under the hood that are establishing correspondence points between different points in the world and that are determining this must have been the position of the camera and the world. This makes sense kind of inferences. So these solutions have been baking, maturing over the last 20, 30 years at least. And inherently, it's all about photometry and computer vision goodies all under the hood. Now, we think vision can actually do much more for this workflow. It is probably the hero on the compute side, but it can actually do so much more if you can bring it to the capture side of the story. So what do we mean by that? What we mean is, what if you could bring computer vision to drones so that they were smarter about what they were doing? We are basically talking about adding intelligence and situational awareness to these data collection machines. For instance, when a drone goes out to take images of a structure it's inspecting, it can be more aware of the scene and of the real world conditions that are out there. It can start sensing obstacles. It can start taking more controlled pictures by maintaining distance to the towers it might be inspecting. And perhaps more importantly, it can be tracking real-time dynamic components of the world out there. For instance, if you want to land somewhere, you want to make sure that there is actually nothing going on underneath. You don't want to be landing on the pedestal or on your own pilot. You want to make sure to confirm this is a flat zone and it's a safe place to land. So in the big scheme of things, I'll be talking about how vision can really make a difference and add these capabilities to drones, overall adding to the really efficiency of these workflows. Our innovation here, we named it Gerbil Ball. Gerbil Ball is essentially a 360-degree safety bubble so that the drone doesn't bump into things and starts making sense of the world around it. Actually, the inspiration came from the pet gerbils. You know how you put your pet gerbil in a ball so it can explore your house safely without getting stuck, getting lost on you? Similarly, you want to put your precious drone and the very expensive laser scanner in this kind of system so that it doesn't bump into things and actually do sort of unpredictable things and can deal with the realities of the world. This is basically one of the early prototypes that I'm holding in my hand. The idea is to implement 360-degree awareness, sensing, which is why we have cameras all around our box, underneath it, and looking in all directions. The fundamental technology we are using here is depth sensing, and we are doing this with stereo vision. Just like we have two eyes, we can do triangulation with our brain. We write algorithms to analyze pictures coming from two sensors simultaneously in deciding what is a safe open space around the drone. This is just one application. You can do many, many more things. You can detect things, you can classify them, you can track them over time. And the idea with this basically is to have this capability right on the drone. This could go as an accessory to a drone, or it can be integrated deeply into your flying machine. Now, one specialty of this is you cannot afford to send the images up to the cloud and get back obstacle information. Everything needs to be done in real time on the drone itself. That's why we have embedded all the computers and all the algorithms within this box so that it becomes a sort of the brains of the drone. So everything is sort of built in here. This happens to be a little thicker printout right now, but we have all our development boards, lots of cables, and all these sensors basically. Sort of for a prototype, this is not bad. Let's talk about different use cases. Let me play a quick video here, and in general start commenting about different scenarios you might be interested in. The idea is to be able to see, sense depth, occupancy, and stuff that might be in your safety zone. As you are landing or taking off, awareness of people around you is very important. If you want to land, you want to confirm that it's a good zone, it's a good place to land. You don't want to rely on maps. If you are inspecting structures, you want to get close but not too close. You want to take good images. And again, we are talking sensing in all directions. The pilot might be paying attention to one direction, but you want to warn him or her if there's something else going on. And power lines, guide wires, all the sort of nasty realities of the world out there that are not on maps necessarily, as well as dynamic stuff, such as other drones, cranes, other moving stuff, trees that might have grown since you have last visited your inspection site. So these are all aspects of the real world out there that are not mapped, that are changing anyways. You just need to deal with them with your onboard computers by deploying some of these computer vision capabilities right on the drone and getting this information out of it in real time. All right, so I'm happy to take questions. We have, in the big scheme of things, we have a lot of other applications going on as well, so drones are not the only one. Automotive safety, video security, retail analytics. These are all domains where computer vision algorithms are making a dent in different markets, and they are helping out. They are helping improve the economies of different use cases. And so if you look at our website, you are going to see lots of different demo videos. If you are interested in those, please let us know. Come chat with us. And if you want to know more about these drone-oriented implementations, prototypes as well, I'll be happy to take your input and questions on those. Thank you very much.
Hey, thanks. I'm curious if you guys are using anything other than GPS coordinates to target drones? Like, are you working on anything where your drones can follow landmarks, like follow a freeway or follow? I saw, it was recognizing power lines in your video, and I thought it would be interesting to get it to follow things along the ground rather than just coordinates.
They could potentially. Theoretically speaking, there's nothing that sort of keeps you from doing that. We are maybe a little too focused on getting this done and done well, but as a core computer vision capability, being able to latch onto visual signatures, track them, keeping them in your focal point, following them are definitely within the realm of what's possible. You have one sensor, you can do 20 different algorithms with them. So the good news is the hardware is there. It's actually sort of the unimportant part of the whole story. It's more the custom software that gives you all these capabilities. And we have done some of the aspects you were asking about, not in the same use case, but I'm happy to take more offline questions. Thank you. More questions? All right, thank you. Have a good afternoon.